Hi everyone. In this video, I'm going to go through what is a first-order linear differential equation and how to solve them. This here is the definition of a first-order linear differential equation. Here we have some examples, and you can see the first one. It matches what's up here. You have the y differentiated, then you have 2x, which is equal to ax. I can type it right here, multiplied by y equal to bx, which is x. So this one here is one of these first order linear differential equations. The second one, again, we have y differentiated plus cosine to x, which is equal to ax, multiplied by y equal to bx. So in this case, we have ax, which is cosine x, and then we have bx, which is equal to 12x. So this one here is also a first order linear differential equation. The second one, so far so good with the y differentiated, but then here we have y squared, and this one should only be y. So therefore this is not a differential equation of first order linear. The second one here, neither, because you have y differentiated twice, and also here you have y squared, squared, and it should be bx here. So these two are first order linear differential equations. Now how to solve them? We can look at the first one. This here is to a formula to solve one of these equations. So what we need to know is what is a of x, the big capital A of x, and we find that by integrating a of x. So a of x, in this case, I can copy paste it here, was equal to 2x, meaning that capital A of x is the integral of 2x, which gives us x squared. Then we also need to know what is bx, and bx is equal to x. So here we have everything we need. So the next step is to replace them with capital AX and BX. So we have YX is equal to E in the power of capital AX, which was x squared, multiplied by the integral of BX, which was x, multiplied by E in the power of capital AX dx plus C multiplied by E in the power of minus capital X. So here I have colored them all. The blue ones are capital AX and the pink one is BX. So this part here is what we're going to look at particularly. So we have the integral of x multiplied by E in the power of x squared dx. So how to solve this one? Here we need to use the substitution method. So we have x multiplied by E in the power of u. We can call this u in respect to x. So here I'm going to say that u is equal to x squared. Now this means that u differentiated in respect to x gives us 2x. And if we isolate dx, we get 1 divided by 2x multiplied by du equals to dx. Now this here is something we're going to use. I'm gonna color this red. So the next step from here, we have x multiplied by e in the power of u. Now instead of dx, we type du here, but then we also have to multiply it with 1 divided by 2x, because dx was equal to 1 divided by 2x multiplied by du. So from here, we're gonna type. We can see that multiplied by x divided by x, they eliminate, and then we have this multiplied by e the power of u. There you have it. Now this integrated gives us 1 divided with 2 multiplied by itself actually. Then we substitute back. U was equal to x squared, so meaning this here is equal to this part. So now we replace them. Given y x equals all this, but this time we replace this part with 1 over 2 multiplied with e in the power of x squared. So from here we could reduce a little bit. We see that e in the power of minus x squared multiplied by this gives us 1. And then we have 1 multiplied by a half gives us just a half. So we get this 1 over 2 plus c multiplied with the rest here. So now we have solved the equation. Now I'm just going to write it down here once again. This here is equal to this. If you need further explanation or another example, just type down below and I will get back to you.